everyone, and welcome to the OldfieldConsultancy AI podcast. Today we've got Kanupriya with us. Kanupriya is in the AI Special Interest Group of the Institute of Science and Technology, which is how we met. Kanupriya, do you want to introduce yourself and give us a bit of detail about your background?
Yes, absolutely, Marie. Thank you for having me. So, yeah, I'm Kanupriya. I currently work in an insurance company. I work within the portfolio steering team, which is part of the property and specialty business unit. So my role mainly involves working on various data analytics and actuarial initiatives to support that business unit, and also sort of contributing to the development of the internal analytical products that our team is responsible for. Before that, I was working as a data science consultant at a startup. So there, my role was mainly developing data-driven solutions for various businesses like finance, retail, and FMCG.
What's the biggest difference, do you think, between being a consultant and an employee within data science? Is there a big difference in what you kind of are expected to do, or the kind of work that you undertake?
Definitely. I think one of the biggest difference is that when you're working as a consultant, you're working across various industries. You don't really have that sort of time to really understand the business and really think about how this all connects, really. So it's just more sort of on a basis of this is sort of the project, or this is the client requirement, and this is the solution you need to come up with. So whatever you're working on, you really have to narrow down on that specific problem. But now working in a business and sort of creating these analytical products and these initiatives, what we really need is sort of look at things from a more holistic point of view, really understand the business. So I think that's the key difference, because you have to spend time understanding the business, understanding the requirements of what you want to do with those analytics, and really meeting with stakeholders and understanding what the requirement is, and sort of then coming up with ideas on what is the analytics that can be used to sort of support the decision making.
So when you're kind of coming up with these solutions and you work in a highly technical area, where do you kind of start? You said that you get requirements from stakeholders, but then where do you kind of start with formulating the technical solution?
So first is, I think, the point where you're really understanding what the requirement is, and then it's translating that requirement into a solution. So the starting point would be, right, so what is the data that we need in the first place, right? And that is within a lot of organizations, right? They're all sitting on large amounts of data. They have different systems where they capture data. And I think the first step is really understanding, right, which is the data that is best suited for this requirement. Then what sort of insights do we want from the data? What are the insights that would directly support the stakeholder in that specific business problem? And then that sort of just flows.
Do you kind of create large technical solutions in terms of using algorithms and that kind of thing? And if you do, how do you start to formulate that?
So my current role is not sort of where we use a lot of algorithmic solutions, but my previous role where I was working as a consultant, a lot of it depended on creating these machine learning models. And that's again sort of based on what one is the requirement. Sometimes it can be done with a very sort of simple technique, just maybe some sort of visualizations, etc., that also help in answering the question. But sometimes if the request is more complex, you really have to think about what sort of models would suit this requirement the best. Then if you have an idea of what sort of models you could use, one is the data that could be used for that specific model. So it's really sort of going back and forth between what model would work the best and the data quality and what sort of inputs you can derive from the data.
When you talk about models, it can seem really black box to a lot of people. I mean, when we're talking about kind of machine learning, I'm not sure what models that we currently class under that, maybe neural networks, maybe kind of speech, that kind of thing. So what kind of suite of models exist for people to use that work in this area that you could explain to kind of the layperson?
That's, I think, a very good point. A lot of time when you're working from someone from a business point of view, it's difficult to be able to explain these models and really understand why you're getting the result that you're getting. And if like you said, if you use something like neural networks, it can definitely seem very black box and then difficult to explain from a business point of view. So that's why I think the key is starting simple, right? A lot of times, like say a simple linear regression, which is something that anyone who's done sort of basic statistical scores is familiar with. But that is always a very good starting point, right? And that really helps, not just maybe if you use the linear regression, you have the result that you wanted, but also it can help in establishing sort of a baseline model. So if you were to use something more complex, right, say a neural network, and it's easy to compare, right? If you're getting a better result with a linear regression than you're getting with a neural network, why complicate things in the first place, right? It's good to go with linear regression because that is something that a lot of people understand, and even if they are not familiar with it, it's very easy to explain just as a simple equation.
Machine learning. So if you've got an algorithm and you're producing output for a certain project, how do you ensure that the process and the algorithm or the program or the model are transparent so that the stakeholder knows what's happening? Because sometimes we can end up leaving models to themselves and they might end up producing something that looks similar to what we expect, but actually they're not processing things in the correct way. So how can we make that transparent?
I think one of the ways I like to handle this is that, say I put whatever my input into the model, and then I look at the output. Can I, based on whatever features that the model is using, can I myself understand why this would be the case? Can I see patterns within the data that suggest that this output makes sense? So I think that's a good starting point, right? So always, whenever you have your output, can we then just look at the raw data, maybe do some visualizations, etc., and see that does this output really make sense? And most of the cases where I've seen, right, it's a clear-cut answer that yes, I see why this is the output we're getting. When it's not, then I think what you could do is start with something simpler, or sort of look at, I think one of the methods that I know a lot of people use is sort of look at, say, a tree-based method, because there it's very clear at what point the data is getting sort of classified or split based on the various input features. So then it's sort of easier to see. And then it really helps in sort of having a visualization of how this machine learning model had actually worked and how the output that we get was actually generated.
How do you go about addressing concepts such as, and these are quite big questions actually, things like fairness and bias? I mean, bias, we talked to Richard Saldana on another podcast about how we would treat it completely differently in statistics from a language point of view, in terms of we might want bias or something like that. But the term bias has kind of evolved in machine learning to include things that are maybe discriminatory. So fairness and bias are kind of two of the buzzwords at the minute. How do you kind of deal with those?
Obviously, I think that's a very, very important topic right now in AI and machine learning. And I think what I would like to do is talk about a very sort of recent example, which was the Apple and the Goldman card, right? Which was sort of being discriminatory. It was offering a higher credit limit to men than women. And digging a little deeper into this, right, what the spokespeople said was, right, we don't know how this is actually discriminating, because we're not even using gender as an input. So this is not possible. And not only that, gender was not even sort of a measured variable, and which doesn't necessarily mean that there was no impact of gender. There could be other variables that suggest the gender, say maybe education level, or sort of how long somebody worked, because there are times, women sort of take a break to raise family, etc. And those are the sort of inputs that may have been still in the model. So whether or not explicitly gender was included, this was still being discriminatory. And by not even measuring gender or having gender in sort of the whole data or whatever they were using, it would have been impossible to detect a bias if it wasn't even tested on gender. So it's really a matter of, yes, of course, you're not including that variable, but you should still sort of test and see whether this algorithm is sort of treating everybody fairly.
That's quite an interesting point, because I feel like maybe if that had included all the information in the model, it might have picked up a lot earlier that it wasn't necessarily discriminating against people, but it was picking up what the facts were in the model, and the societal kind of implications were, like you say, if a woman takes time off to raise a family, then maybe it's not going to give her a big enough kind of credit card or a credit card at all, because the man's actually earning and the woman isn't, but the woman is using the household income. So actually those societal nuances are not being picked up in the model. So is there a way in which we can kind of maybe include this, or maybe look at protected characteristics? Should we maybe include those? We don't have to declare them at the end, we can probably remove them at some point, but should we be testing on them?
Yeah, I think, of course, a sort of holistic test before something like this, something that a major is sort of rolled out to the public. I think it's definitely a full-fledged testing should be done, just to not only make sure whether the algorithm is working fine or not, but also identify areas where it's not working. So not only is it important to sort of see where it's going well, but also really understand the blind spots of any model. So I think that's a very important issue for to handle something that's sort of this sensitive, is that really also checking on what the blind spots of the model could be.
Yeah, I think that's so important. I think there's so much kind of, especially kind of in justice type algorithms, where you're looking at disproportionate treatment of Black communities and white communities and that kind of thing. And it's not necessarily to do with that, it's to do with where people are situated and what's going on in that area and that kind of thing, this information is not getting fed into the model. And because of that, the model is only able to work on the pure data that it has, and therefore it's exactly. Just not able to understand enough to do something that's reasonable for society. And then that can even be amplified, where the model suggests certain things, but actually these things are massively discriminatory, but it's because we've not picked up the societal nuances in the first place.
Absolutely. So if your data has these biases in the first place, that's what a model will give you as well.
Just to pick up on the language with this, because this is something that I've been researching. When we say the data's got biases in it, in statistics, we would just look at that as that's what the data is and that's what we're working with. And if that whatever comes out at the end, that's what it is. But this has evolved into now we're saying that the data's got the biases in it. When we're saying that, I'm interested to know what it kind of means, because does that mean that the data is reflecting society, or that the data is reflecting biases in society? Because I think when we say the data is biased or the model is being biased, it seems to me to be a bit of a language issue, which is saying that the algorithm's biased, and the algorithm can't itself be biased. It has to just do what it's told to do, but on the data that it's given. What do you think to that kind of terminology?
Yeah, I think that's absolutely sort of a gray area, right? So when you say that this is what the data represents, right? It might not necessarily be that there was something wrong with the data, but it's just how it just reflects the biases that already exist in society.
Do you think that there's something to be done within kind of unit testing where we're doing validation and verification of models? There's something there where we can do, a whole lot more testing to determine, kind of use societal scenarios maybe, and put different types of, this is a lady that's at home and she's looking after her children, this is a man that's at work, what happens, what's the difference if we put different permutations of this testing, what happens? Is there more that you think, because I'm not really involved in testing at the minute of different models other than kind of military models, but if you were going to do this in kind of finance or something like that, do you think there's more to be done in terms of testing?
Yeah, absolutely, right. But I think it also sort of gets to the point, right? When you're looking things from sort of a business perspective, right, there's always timelines, there's always budget constraints, all of that. So a whole full-fledged testing is not something that's always possible, right? And it's usually sort of all of this whole process needs to happen very quickly. And there are a lot of areas where things could be improved, right? Even sort of the whole data collection process. And like you suggested, right, try out different permutations and combinations, but also keeping in mind, right, from if there's a big business and if there's constraints involved, right, this is not something that is always possible and would be good to have, would be ideal, but in the real world, right, it's not something that's always possible.
Do you think that's a large ethical consideration, the fact that we might not have the budget or the resource to test well enough before this kind of model gets implemented? And in that, I refer to kind of, the Home Office algorithm that cost a lot of money and got pulled out, the Apple Card that created a lot of PR issues. Is it worth putting more effort up front to avoid these types of problems when we launch models?
Yes, absolutely. I think it's one, how sensitive the subject is, whatever the model is being used for, right? And one, how large scale it is, how many people does it affect? If it's something that's extremely sensitive, and if there's something that's large scale, yes, obviously, I think that's something that really needs a full-fledged testing, a more thorough testing, and making sure, right, this doesn't sort of create any fiascos similar to Apple.
And just to kind of round up with my last question, you were recently featured as a woman in tech at the Institute of Science and Technology. What would your kind of advice be to women that are coming into STEM that are maybe unsure about taking a career in STEM? What would your advice to them be?
Yes, so I think one thing also to keep in mind, right? It's becoming sort of more open. I see a lot of women in tech roles, a lot of women in sort of data science roles, and I mean STEM roles in general, right? So it's a good time to be here. It's really, I think, and there's a lot of awareness as well, right, of how important it is to have sort of more gender diversity on different teams. Right. So I think with that view, right, it's just like, don't shy away, be sort of courageous, right, and really have confidence in yourself. And I know that there's a lot of times I've been told, right, there are not many women who code. When I say, I know how to code, not many women, who are good at math, and these are something that those are perceptions within the society, right, and those are not true. There are women who can code, and if you want to code, go ahead and code. If you want to study a STEM subject, right, that there should not be anything stopping you, right? I think it's been a long time coming, and it's time for women to shine in these fields.
And women can code just as well as men. I mean, we're both
absolutely.
in maths. So yeah, you can actually be in maths and, do well, I think, and still be
absolutely.
a female. Oh, thank you so much, Kanupriya, for being part of the podcast. It's been an absolute pleasure to have you with us today.
Yeah, thank you for having me.